It is April 6th, second period, 2011, and I'm about to display a think aloud strategy for you to do in your groups after I show it to you. So watch. When you kick a soccer ball along the ground, you know that when it stops kicking the ball, eventually roll to a stop. No duh. That's what I'm thinking. Everything that I've ever seen stops. But Mr. Schmidt has been trying to convince me for a few days that conservation of energy means that energy is never lost nor gained. He's right. A ball should never stop rolling. We all know they do. So, yeah, big deal. It must have something to do with energy transforming. And I'm going to look down a little bit further. Oh, look. Essential question has the word energy transform. Investigative question talks about transformations. And my guess is that this lab is going to be about energy transformations. At least I know what it's about. Essential question. He's going to ask me to write about energy transformations in general. The investigative question must be more specific. I usually look for information that's going to help me with my experiment design. And as I look at the essential question, the investigative question more closely. I see something about rolling surface and energy transformation. I believe if I answer this question, I would have my hypothesis. And I could predict that certain rolling surfaces will cause energy to transform differently. I also know from experience that when I roll a car, when I was a little kid, I used to roll cars, and I used to try to roll them on the carpet. My house was covered with carpet, and I'm thinking, why won't the dang cars roll on the carpet? And then I go to the kitchen, that's the only place I could roll it and have fun with it. Of course, my mom doesn't want me to roll it there because she's in there and doesn't want me to, doesn't want to step on cars. So here's my prediction. My prediction is that a smoother rolling surface is going to allow the car to roll farther. That means that the energy transformation is different between surfaces like carpet and surfaces like linoleum. How they're different? Well, it seems to be that on a smooth surface, energy transforms more slowly than on a rough surface. Maybe I should say it differently. I'll have to ask Mr. Schmidt in class about that, because maybe instead of thinking it in terms of speed, maybe I should be thinking of it in terms of distance, or maybe I should be thinking of it in terms of heat. I don't know, I'm going to have to ask. But I will. Anyway, my hypothesis will be that the car will roll farther on a smooth surface than it will on a rough surface. Meaning that energy will transform less quickly, or something like that. I'll have to ask in class to make sure I'm clear on it. Procedure starter. In order for me to compare these results, I will need to make sure that I have the same starting energy. And that's really hard to do because I can't push a car and know that the energy is always going to be the same. The only thing I can think of, and what we've been learning in class, and what he says right here, he uses the word gravitational potential energy. The only thing I can think of to have the same energy at the start would be to drop the car from a set height. And when I look down, the procedure starter, the very first sentence says make a ramp. That must be how. But you know what, I'm going to reserve my judgment and think about it. I'm sure, just like all labs, when we get to class, there'll be some sort of example or demonstration of how I might do the experiment. So I'm thinking I'm going to make a ramp. The hypothesis will be that if I start all the cars at the same height, that depending on the smoothness of the surface, that will determine how far the object will go, and that'll tell me how long it takes the energy to transform, or how efficiently that energy transforms into other forms of energy. Some variables, distance would be my, oh geez, I always get it mixed up, independent or dependent. Dependent is the thing that I'm looking for, so that would be my distance, would be my dependent variable. And my independent variable will be the type of surface that I'm rolling on. Smooth, carpeted, sandpaper, whatever Mr. Schmidt offers to us, or maybe one of my group members will want to bring something in. We'll see. So he says make a ramp. Well, we'll have to think about that. I'm sure there'll be some supplies for that, but I can imagine making a ramp out of a textbook or a piece of paper or cardboard, so I'm sure we'll be able to come up with a ramp. The ramp height must be important because we'll be able to calculate GPE. I know we've been experimenting with GPE in class and talking about how to calculate it, so I'll probably ask some questions about it, or somebody else will ask questions in class that make it clear how to do the calculations. Oh, other data that might be useful. Since I don't see distance on the data table, I bet you I must have to calculate or measure distance as one of the dependent variables. And as I look down a little further, these labs, I don't usually think about the analysis and conclusion until I've written the experiment, until I've done the experiment and I'm about to write it up. So I'm just going to wait on that stuff until later. So I think that me and my group would be able to design an experiment based on that thinking.